But one of the things that's really clear is that if you're able to reduce the attack surface, you can actually prevent those vulnerabilities from being taken advantage of by an attacker. So that's an example of how we're making IE7 more secure through the SDL. Another thing that we're doing is that we're improving the code quality of IE7. So we're rewriting important sections of the code based on the threats. So we understood, based on the threats and based on the threat model, that URL parsing is incredibly important, and that getting that right every time is incredibly important. So we rewrote the code that does URL parsing to consolidate it into one single function so that that's done consistently and that there aren't disconnects when we're evaluating things like the cross-domain boundary. And then a third principle that's going to switch us into another, we're going to switch over to another kind of data flow diagram here. A third principle is this idea of defense in depth. And John Lambert talked about defense in depth earlier today as one of the ways that Microsoft kind of adds additional protections, because we know that no matter how much security work we do, there will still be vulnerabilities in the code. So we add defense in depth in order to make exploiting those vulnerabilities more complicated for an attacker and give users an extra layer of protection. So I showed you this high-level diagram of the IE process, and I said, well, there's not much you can do here except just disconnect the internet in terms of protecting the user. But one of the things that you can do is that you could potentially add a new boundary and reduce the privileges of the entire IE process. So here, what I've done is I've tried to change that data flow diagram to show you that we've taken Internet Explorer, and by coloring it orange, I mean that it's now less trusted, and we've reduced its privileges. And we've added another boundary, and that adds additional complexity in order to realize a successful attack on an end user. This diagram doesn't do the work that we've done justice. And what I want to do is I want to focus on these three features to illustrate them. I'm going to demo these three features for you. Before we move on, I'll say that these are just examples. These three features are just examples of a lot of other feature-level investments that we've made in order to make the system more robust. Again, even this more verbose slide, simply examples of things that we've done to make the system more robust, where there are tons and tons of fixes, particularly from the fuzz testing effort that we've done, that simply are never going to be kind of applauded and lauded, but really have helped make the system a great deal more robust. So now I'm going to switch over to the Windows Vista system, and you'll have to bear with me while I get it projecting again. It's always fun to come back. Okay, so looks like we're successfully projecting. So I told you I wanted to show three features that help protect the user. I want to show how we reduce the attack surface with ActiveX opt-in. I want to demonstrate something about URL parsing, and then protected mode. So I mentioned my brother, who seems to be willing to do anything for free music. Free photos aren't far away. So like all good attacks, we start in my brother's inbox. And here, when I go out to this website, the first thing I notice is an information bar that's, in this case, actually not telling me something particularly useful. But there's actually a ton going on in this page. So I'm going to click on this information bar to see that, hey, there's something going on with add-ons, and there's something going on with an international website. So let's take a look and see what this website's trying to do. So this website is using a demo ActiveX control that we built, and it's trying to write a local file into the user profile, start menu, blah, blah, blah. So we all know where this is going. This isn't a good thing. It's not a good file, and we don't want it to be dropped into that folder. Well, because of that feature ActiveX opt-in that I told you about, add-ons have been disabled by default on the system. So this ActiveX control isn't running in the page right now. And that means that we've eliminated that attack surface from the user's default system. So this attack has already failed. But let's look at a couple other things. Well, the address bar kind of looks like garbage. I don't understand what website we're actually at. If I click on this international website address flyout here, I can look, and I don't know if you can see on the monitor as well, but it says that native language address is KatossoPhoto.com. Imagine KatossoPhoto.com were a real business, like, for example, a Snapfish or a Kodak website. And imagine that an attacker was trying to make their URL look like that. Well, we added support for international domain names in IE7. We added a feature that actually adds some potential security surface area. But because we were able to consolidate the URL parsing logic in one place, we felt confident about adding that feature. And then, in addition to adding that feature, we added secure defaults for that feature. So we decided that if a website address includes a Cyrillic character from a Russian character set that's easily confused with a Latin character that we use in English, that's a potentially malicious URL. And this is a way that we can help be secure by default against attacks through international domain names. So this website's failed in two ways. It failed to run that ActiveX control and use it to attack me, and then it failed to kind of con me into thinking it was a real Contoso photo website. So my brother, on the other hand, shoot, he's really dedicated, and he's going to get this free stuff no matter what, because he knows that I'll be around to clean up the system, shortly, right? So let's get him to run this ActiveX control. And the information bar is still showing because of the international domain names, but the ActiveX control is now running on the page. Okay. And let's go ahead and when we click through there, that should have dropped the file into the startup folder. Let's go look in the startup folder. Well, the startup folder is empty in this case. When we saw that successful attack on XP, that mocked up attack that I showed you at first, evil.exe ended up there. Here it's empty. And what happened is that Internet Explorer is running in protected mode. And that means that Internet Explorer, the process, has been specifically configured to have access to the temporary Internet Files folder, but not necessarily to have access to the rest of the system. So that's kind of a bit of an obscure concept, and I've got another diagram here that can help kind of put this in context. So before I talk about Internet Explorer in protected mode, I want to talk about IE running as an admin. Who here runs their system as an administrator? Go ahead and admit it. I don't believe you. So if you run as an admin, then that means that processes that you run are running with your privileges. Internet Explorer's main job is to get HTML and to get images and to put them together and show them to the user. On occasion, Internet Explorer goes ahead and downloads an image and the user wants to save it someplace. And in that case, maybe they save it into the My Documents folder. And that's a more important folder because stuff that ends up in the user's profile might potentially get reused, and we saw that startup folder that I keep trying to attack. On rare occasion, those admin rights really come in handy because the end user decides that they want to install a new extension for their browser. They want to install a new ActiveX control. They want to get Flash, they want to get QuickTime, they want to get Real. All of those are important extensions that are important to the way that we all experience the internet today. So it's important for the end user to be able to get them. So IE runs with admin rights for just that scenario. Well, if IE is running with admin rights for that scenario, then IE can potentially, if it gets tipped over, drop malware into a system part of the system, an admin rights part of the system. Excuse me. Well, and you keep seeing me try to attack this startup folder, so we know that there's ways to kind of put some maybe less powerful attacks and less powerful malware into the startup folder. So it should be really clear that, well, maybe IE doesn't need to be running with that level of permission by default. And a secure default way for IE to run is to run with the least privilege. So with protected mode, we've configured IE so that it has access to the temporary Internet Files folder, because that's its primary job. Now, if the user wants to download a picture and save it in their My Documents folder, we still have a separate process that's able to prompt the user with the same experience the user's always seen and let the user save that into the My Documents folder. But it's not in the primary IE process. And then, again, to reduce attack surface, we've been able to separate the ActiveX control installation part of IE into yet a separate process that only runs on the rare occasion when the user is going to add one of those add-ons to their system. So now, as soon as you see this architecture, you think, well, that's going to help make the system safer. But what about that toolbar that I've been running inside of IE for so long? What about that thing, I've typed all my favorite searches into that one toolbar, and if that's, going to try to write to the registry and if that's going to fail, then my toolbar's not going to work anymore. So we built a redirector that runs inside of the IE process, and if there's a part of the system that needs to, if there's a part of the IE process that needs to write to a user rights part of the system, we're able to redirect that into the temporary Internet Files folder or an analog to that in the system registry. Now, if that is true, that the compatibility redirector is running inside of IE, well, what happened in that attack that was targeting my startup folder? Let's go back and look at my startup folder and see what really happened. Well, we saw that my normal startup folder was empty. But here, what's going on here? This is a virtualized, dynamically built fake copy of the startup folder that IE built so that that extension running inside of IE could think that it was putting a file someplace successfully. So you can see how we recreated that path to the startup folder. Now you say, well, isn't that dangerous that this file is there? Well, the user's never going to find this, and this isn't a place that's going to automatically be built to launch this file. But even if the user were able to find this, or this file somehow tried to automatically launch itself, we've added another protection in that when IE wrote it, IE wrote this file with the same permissions it had. So if this file tried to get out and do something that it wasn't able to do when it was running inside of IE, it's also going to have, it's also going to face some more obstacles in terms of the permissions that it has on it. And then one of the things that I like to show security folks, because I think we all want to be able to do this once in a while, is, hey, I want to be able to clean all the garbage out of my system. So with IE7, we've made it really easy to go ahead and delete, even some of these things that have been stored in the virtualized part of the system here. And if I go back, here you can see how I was able to clear that out. So you can start to see how this combination of attack surface reduction and code quality improvements and defense in depth helps to neutralize some of the threats that we've seen in the past. Now, we've also, I said we were going to protect the system, and we're going to try to protect the user. So let's go back to this threat model. Now I could start talking about pop-up windows attacking the user, and I could start talking about, URLs getting out of sync and interesting things like that. But I've got a bigger problem on my hands. Like I said, when I go home to visit the family, I've got John Franco, serial downloader, and he's installed whatever free music sharing app du jour he's been able to get his hands on. And as a result, well, let's just say there have been some attacks and compromises around the Franco family household. So let's go back to good old John's inbox and look at some of the attacks he might see. So believe it or not, this kid's getting married next week. It's shocking to me, and the rest of the family is now starting to think that I'm the up next. So there's some serious issues going on there. But let's look at one of the emails that John's going to get after he cashes all of these wedding present checks. None of them will come from me. So he's going to get some friendly reminders from his bank. And what happened here is, of course, that was a phishing email. After John went to the phishing website, IE was running its phishing filter, and we were able to call a web service in the background. Now, it turns out that this particular site is a known phishing site that we've detected, and we've been able to populate up to a web service. So the web service sends a message back to IE and says, get the user out of there. We get the user out of there. We don't prompt them and ask them if they'd like to continue, if they think this is a fun place to be. We just get them out of there. Since this is since all of these blocks have come back as a result of the web service, we know for sure that we've been able to block about 150,000 confirmed phishing sites across the 10 million users who've downloaded IE7, and that's over the last 3 months.